As evidence builds for Planet 9, some astronomers are asking a bold question. What if there's no Planet 9? What if, instead of a single massive planet lurking in the dark, there's a swarm of smaller objects, icy bodies, perhaps hundreds of them, scattered across the outer solar system, whose combined gravitational pull mimics the effects of a single world? This theory is known as the distributed mass hypothesis, and it's gaining attention. It suggests that the unusual clustering of orbits among ETNOs could be the result of many smaller forces acting together rather than one dominant planet. Like a group of rowers, each tugging slightly on a boat, their collective pull could slowly steer the ship, even if no single rower is strong enough to do so alone. It's a compelling idea, but like all scientific theories, it needs strong evidence. Right now, that evidence is missing. We've detected only a small handful of ETNOs, and their distribution suggests a more centralized influence, something massive, steady, and consistent. But that could change. Enter the next generation of sky surveys. Projects like the Vera C. Rubin Observatory are poised to scan vast areas of the night sky with unprecedented depth and clarity. These surveys may reveal new distant objects, mapping their orbits and refining our understanding of what lies beyond Neptune. If astronomers discover dozens or even hundreds of mid-sized icy bodies spread across the outer reaches of the solar system in patterns that align with observed gravitational anomalies, the distributed mass idea could gain serious momentum. But if those objects fail to appear, or their arrangement doesn't support the necessary gravitational influence, the theory will weaken. Still, some researchers propose a hybrid solution. Maybe Planet 9 does exist, exerting the primary gravitational influence that shapes the ETNOs. But perhaps it isn't working alone. Perhaps there's a background population of other distant bodies, minor players contributing subtle gravitational nudges that add up over time. In this picture, the distant solar system is shaped not by a single architect, but by a hierarchy of gravitational forces, one dominant entity and many lesser ones. It's a layered structure, one that would mirror how gravity works throughout the cosmos. This wouldn't be unprecedented. Even in the inner solar system, small gravitational effects can have large consequences. For example, the Yarkovsky effect, a tiny force caused by sunlight warming an asteroid's surface, can gradually shift its orbit over decades or centuries. So while Planet 9 might be the main character in this cosmic drama, the ensemble cast of smaller objects could still be shaping the stage. But what makes Planet 9 such a strong contender is its ability to explain multiple phenomena at once. It not only accounts for the orbital clustering of ETNOs, but also explains the high-inclination objects, the strange orientation of the solar system, and possibly even the missing mass needed to model outer solar system dynamics accurately. No other single hypothesis ties together so many loose ends. Yet the scientific process demands caution. Astronomers are developing increasingly detailed simulations to test all theories: Planet 9, distributed mass, hybrid models, and more. They're comparing predictions against real-world data, checking for consistency, and searching for anomalies. And that's the beauty of this mystery. Every possibility leads to discovery. If we find Planet 9, we'll have redefined the map of our solar system. If we don't, we'll uncover an even stranger reality, one where many small bodies, collectively, bend the gravitational structure of our cosmic frontier. Either outcome reshapes our understanding of planetary science. As telescopes become sharper and algorithms more precise, the truth will come into focus. But for now, we're left with possibilities, each one exciting, each one pushing the boundaries of what we know. In the shadows of our solar system, something is shaping the orbits of icy wanderers. Whether it's one massive planet or a crowd of smaller ghosts remains to be seen.